Okay, so let me share a screen here and close this up. So last time I talked about shader graphs, and one thing I forgot to show you was my DogVision shader. And so out on the American Kennel Club is this article about can dogs see color, and this is what the world looks like, and this is what the dog sees. It's a well-known fact that dogs are colorblind, and some people think that they see in grayscales, but they don't. What's different about the dog's visual system is that they don't have as many different kinds of cones as we do. We have three different kinds of cones. We have the red, green, and blue cones, which is why we always use RGB systems. But a dog, where's the RGB here? I don't know where it went. Dogs only have two cones, one kind of a blue one, and the other that's kind of on the border of yellow and green. And so we're trichromatic, three different kinds of cones. Dogs are bichromatic; they have two different kinds of cones. So I wanted to use shader graph to somehow make a shader that depicts objects the way dogs see them. And so I'm going to try and turn this rainbow into what a dog sees, which is the picture that I got here from the Kennel Society site. So in my DogVision shader, in the blackboard of it, I have an albedo, which is the texture that I'm going to be converting into DogVision. I have then three float parameters for the final weight: the yellow, green weight, and the blue weight. So the dogs see yellow, green, and blue, and I have this final weight that was just another adjustable parameter. So I take the albedo, the texture that I'm fiddling with here, and I feed it into a sample texture 2D node, and I send the red and green channels to an add node. The blue I just send on, it's going to be added in later, but the red and green I have to combine into this kind of yellow that is what the dogs see. So the output from the add that has added together the red and green goes to a mixer node. And there's an arbitrary multiply by a quarter there that I put in just to kind of scale things down a little bit. So a channel mixer lets you take each of the red, green, and blue channels and modify the amount of red, green, and blue that is in each of those channels. So the three setups here, in the red channel, I'm passing 1 unit on. In the green, in the red and, no, 1 unit of red, 1 unit of red and a half each of red and green. And this was a lot of fiddling to get it to kind of look right. And nothing in the blue channel. So here's the blue channel over here with nothing in it. I'm combining red and green here into the green channel, and I'm passing the red channel on directly. So the output of that goes to a multiply node where I scale it by that yellow-green weight that I had a settable parameter. And this then goes on to a split node. And the split node now takes that and splits it into red, green, and blue channels. I take the red and green channels and multiply them by the blue weight. Oh wait, the blue channel has been multiplied by the blue weight. So that's this one here. And then I take those red and greens from the split and the blue from the blue weight and combine them. And that RGB then goes to a multiply where I have this final weight that I can multiply it by to, make kind of a final adjustment. And then this goes on to the color of an unlit master. The masters I showed you last week were the PBR, the physical-based rendering masters that use lighting, but this is the unlit master that's just going to render the color on the object. It's not going to do any lighting. So this turns our rainbow into this. There's a yellow-green kind of selected from right about here, and there's a blue channel that's kind of passed on exactly the way we want it. So this is what I settled on for my my shader, and here's the whole thing. So what's this look like in the world? Well, here's that shader, but no, this is the kind of a rendition of the standard shader that has a contrast and some other stuff here. You can look at that later. But the main thing here, let me get in a different view. The main here is for my little yard scene that I've got. Play. This is kind of the standard picture, the texture of the yard scene that I'm looking at, and this is what it looks like for the dog. This is, on the right here, is another version that I attempted and was not that happy with. You can look at that failed version. It turned out being just kind of brown. But I was pretty happy with this one. This kind of looked like what one would want, a little I'm sorry, I'm looking at the chat and it's not relevant. All that said, all I'm looking at here is objects with materials on them, materials that are using these shaders. But really, I want to be able to walk around in the world and see what the dog sees. And so, and this is kind of a fudge. I'm sure there are other ways to do it. And it actually occurred to me 15 minutes before class that I could use a UI that covers the entire screen, that has the camera rendered texture on it, and that would then cover things up. But the approach that I took here was that I have a camera that is pointed at a quad that I've got up here in the world someplace. I've got this quad set up here. Whoops. I've got this quad set up here someplace that has the a rendered texture from a camera on my player. So my little player has its ordinary camera that's in the first person character, but it also has this camera that is sending it to a render texture. The render texture I'm putting on this material using the shader that I've got, and then I have a camera that points at this quad, and I'm displaying it here in the lower half of the screen. So in the upper half of the screen, we see what the ordinary camera sees. And, here's my rainbow object over here, which very clearly in the dog view down below here looks the way I want it to. These primary color, these are fully saturated red, fully saturated green, fully saturated blue, and then the three complementary cyan, magenta, and yellows. And this is what the dog sees. The dog sees a blue one, and everything else is kind of a shade of yellow, green, and magenta and cyan, because they just turn out to be gray, because their channels just end up being all the same. And here's just a picture, out of the way there, a picture of a pile of flowers and stuff on a table that I set up. So that's my dog vision world, and this is what a dog sees. So that's shader graph. Now, the other thing that I want to look at is another URP, HDRP tool, and these are tools that are only available in the programmable render pipelines, the visual effect graphs. And these are, I'm sorry I haven't updated this one. There's a couple of links and a nice tutorial system, or tutorial on the learning site. I'll update that before I post it. But this is an alternative to the built-in particle system that we have used, the Shuriken system. And this is the visual effect graph. The advantage of VFX is that it simulates on the GPU. And it's very clear that this is a spin-off of the shader graph, because the whole way of manipulating it with modules and wires that connect different components and multiply and add and all these other things are available in VFX. So it's kind of like the shader, but the bottom line is that VFX simulates on the GPU instead of the CPU. The Shuriken particle system works on the CPU, although the particles are on the GPU, but the thinking that goes on in Shuriken is all in the CPU, whereas VFX does all the thinking of how our particle plays in the GPU. And so you can get a lot more particles running with a VFX. It's a package that you have to install along with either the universal or high def render pipeline. And as I said, it shares a lot of features with shader graph. So let me close this one out and get which one is it? I think it's this one. So we create visual effects. This is one of the project views pull downs: create a visual effect graph. This creates an asset template. So there is kind of a default template that comes up when you create one. Once you've created a VFX, you can drop it into any of your objects. So here's, whoops, don't do that. So here's an empty scene where I've created a new VFX, and it has this default VFX. Here's what the default particle system looks like. It's emitting particles in a cone that have a certain lifetime, and they go up and they do something, and they have a default texture, which is this little clock. And if we look at what that looks like by editing it, which then opens yet another window, we have this arena for playing with this. The A key focuses it, and we now have the 4 basic modules that represent how our particle progresses from birth to rendering. And it's got a blackboard where we can define input parameters, and it has this target gain object where we can attach to an object, and it will then render in the scene. So I'm in the wrong window here. So the basic template has all the pieces that you need. And there are 4 basic graph units called contexts in their nomenclature. There's the spawn, the initialize, the update, and the output. And there are a couple of different outputs. You can output lines, cubes, triangles, meshes, but the quad is kind of the basic one that we're familiar with from the built-in system. This is just like the little quad that the Shuriken system makes that faces the camera in an ordinary way. And each of these contexts contain blocks that define the behavior of that specific context. And so if we look here at the spawn, and here by clicking on that, so it's highlighted, and pressing F, clicking on it and pressing F, it zooms into that. So this has the spawn has a constant spawn rate of 16 per second. And there are other blocks that you can put in here for spawn by distance and so forth. Each of these blocks have properties. We see in the spawn rate, it has this place for input of the rate. If on the blackboard we had a float that was the number of particles, we could, just like with the shader graph, put it in the scene and connect it by a wire to that rate. And if that were exposed in the inspector, which is a little check mark, then you'd have that exposed on the shader, and you could affect the number of particles, not on the shader, but on the system, and you could affect how they work. There are similarities between the modules of the built-in system. Like with the Shuriken, there's that top module that is permanent on all of them, that has the lifetime and some other capacity and other stuff. They're kind of mixed between some of the different components, some of the different contexts, but the same tools are all there, and supposedly we get more control over this. So the simple particle system, so let me go back, let me close this. And auto here, I believe means that when I close this thing, it will automatically compile it, although you can press the compile button and it will compile as well, but I'll close that and you'll see some shading. So here in this simple scene, I have a shader, I have a particle system, simple VFX. So I think all I've done here with this one is I now have an exposed texture that I can now add to my particle system. I believe everything else here is kind of just the default. But I do have this exposed texture. The default is, you can put a default texture in here, the default particle, but and you can close these up and close the blackboard. And so that's the particle. And down here in the output field, I have that texture connected to my main texture. And then there's some other blocks here like orient, face the camera. So that's the ordinary way. Size over lifetime is on a little ramp, and a color over lifetime has a gradient that fades in and fades out. So those are 4 blocks that we put in the output quad that affect its appearance. That's then this simple little shader that makes particles with a specific texture, and they fade in and they fade out as they go over their lifetime. So that's a simple one, and really it's not a big deal. It's the same as shuriken. So one of the things you could add, you can in each of the contexts, you can create a block by right-clicking, and then a context-sensitive menu comes up with available blocks that appear. So it's got a little search window, so if you know the name, you can find it quickly. And you can add gravity to the update, and the particles will fall. So we can basically recreate everything that we've got. Now, there are some other templates that come with the instead of just the simple one. There's also templates for the heads and sparks, and this, of course, is a slightly more complex example of a particle system with some noise and some trails and some stretching of the particle. And I'll let you look at the shader, not the shader, but the VFX graph for this. It's not terribly complicated, but it does have more things going on with it than just that simple shader. So it actually has 2 pathways through here. This is one pathway making a particle, and when it gets to the end here, the particle update, it takes the output of that and passes it over. And let's see, I got to do an Alt in order to pan, and that sends it over to this GPU event that then spawns another event. So that's kind of the way the sub-emitter works in this system. We can take the output of one particle system and use it to trigger another particle system. And here's what the head and, oh, there are no exposed properties for that. There's heads and trails, which is just another example. And these are all templates that come with the thing. And of course, are good starting places to look at how they do these different things. Here's ribbons. So this one is some kind of ribbon that circulates around in the world. And the other cool one is swarm, which kind of is a stress tester. This one makes 65,000 particles and waves them around with Perlin noise, and I'm getting 125 frames per second out of with 65,000 particles. And just kind of to stress test this, I have a particle system that has a color over a lifetime. It has a minimum rate and a maximum rate, and a speed, which is how fast it progresses from that minimum rate to that maximum rate, and then lifetimes of my particles. And I have various UI elements that I use to catch effects that are going on here. So the instrumentation here, this is writing out things to a file for future plotting. And this is updating the UI elements with how many particles there are in the system and some other stuff. And so this starts off kind of slow, and is recording. It'll record for a full minute, and we're recording the frame rate, which of course is a bit slower because we're also zooming at the same time. But I believe by the end of this, I have 1.5 million particles running in the world. And I won't go to completion here, but I'll show you the little plot that I got when I ran this earlier. Whoops, I just broke it. Darn. When I ran that, I broke the file that had the picture in it. Sorry. But you can run that, and it makes a little XY. It makes, it's not even there. It didn't flush, so it didn't, it's not there. Sorry about that. So this lots of particles one is worth having a little look at, because in the way of thinking with this thing is we have kind of a vertical pathway, and we have horizontal pathways. And the horizontal pathways feed into these different options on the vertical pathway. So basically here I'm looking at the spawn rate and what I want to have for my spawn rate. And I want it to vary with time as time progresses here. So like with the shader graph, I have a time module here, and I'm multiplying it by the speed. I'm multiplying the output of that by the maximum rate. So, this is some amount smaller than the maximum rate, which I then add to the minimum rate, and then make sure that I have not exceeded the maximum rate by making it the minimum of those two, and that just goes directly into the rate. So this horizontal pathway feeds into the vertical pathway that then does our different particles, or our different inputs. And down here I have the two exposed variables for minimum and maximum rate. So I can set that random between these two values and have them go. It's emitted on the surface of a sphere with radius 1. And in the update particle, I'm using a turbulence module, which is noise. And I'm using Perlin noise, and I have various settings for the intensity, the drag, the frequency, all these other things. And finally, in the output quad, I just have a size by speed and a color over lifetime that is apparently also added to an exposed variable in the blackboard, which is color over lifetime. This is my little gradient that I apply to color over lifetime. So let me close that and close this. And there's, on the Unity's GitHub, there's a set of much more advanced topics. The visual effect graph samples 7.5, and I extracted just a couple of these because it's a 1.2 gigabyte download, and it's a big file when it gets expanded, and it's got a lot of different examples, all very, very complicated. But I want to just show you two kind of simpler ones that they provided. Unfortunately, this is an HDRP, which my computer doesn't really like very much, but it's not doing too much fancy HD, so it does kind of work. But right off the bat here, here's one of their samples, the butterfly. And so this is making butterflies that flutter around in the world. There's a bunch of post-processing going on here for depth of field and bloom and other stuff that's all HDRP kind of stuff, but it does look pretty cool. And these are little butterflies that flit around in our world. And let me kind of look at the shader for this, the butterfly. So not the shader, but the visual effect graph. And this one is quite a bit more complicated, but is quite instructive for how things work in here. So right off the bat here, we've got a bunch of stuff in the, whoops, I wanted to turn that off. In the inspector, we've got velocities, flapping speed, flapping angle, flapping amplitude, tilt of our bugs. And so a lot of different inputs that are placed in our VFX. And we have the vertical pathway here that has the, whoops, I hate this interface because it's just really bulky. So we're starting off with the spawn here, 50 particles. We're moving down to an initialized where we've got some bounds. Our position is a sphere. We're randomly spawning within that sphere. Here's some input from a horizontal pathway, that's the direction. We've got random velocities and speeds here. Here's some annotations, some actual comments that are added to this that hopefully help explain how things work. They're just different little contexts that you can make into sort of post-it notes. We go on down to the particle where we're getting the velocity from a horizontal pathway. And we're using that turbulence module that has a time clock that's affecting the Y component of the turbulence. We've got stuff going on with the velocity that's coming from someplace, and we've got scaling and where the pivot is on our little particle. And at this point, we have a particle, but we haven't actually added any rendering to the particle. And here's where the clever part of the butterfly comes in. We send that particle to 3 different outputs, 2 lit quads, 1 for each of the wings, and a mesh for the body of the bug. And so all of these are getting things that adjust their orientation as they move around here, all coming from horizontal pathways. But the Flapping of the wings is done by setting the angle. And so all of this stuff is being handled by these relatively complex, and I won't go through any of them, horizontal pathways that feed into all of these exposed settings on the different vertical component modules. And so that's all pretty cool. And I'll close that, and I'll show you one other example that is the ribbon. So the ribbon, don't save. So the ribbon is just another of these complex examples. It makes gazillions of these ribbons these are kind of solid looking. They have shading on them and shadows that they cast and are cast on them. And the whole concept rotates using, I think it's using one of the player things. But this particular shader looks like this. Here's the ribbon shader, not shader, VFX. I'm sorry, I keep calling it a shader. It's not. It's a VFX graph. So this one has two exposed variables, I believe, the phase of something and the spawn rate for the trails. And this one again is one of these examples of a sub-emitter, in that when we get done with this vertical path, we trigger another vertical path by taking and connecting the end of this to the spawn of this. And so, one of these is making the particles and the other one is making the trails. And it has a horizontal path here over here that does something with the phase, and the colors are done with fancy stuff here. And so I'll again let you attempt to read through this. My big criticism of these, and if you do download that visual effects package from the Unity GitHub and look at some of the really complex ones, everyone used to criticize Fortran for being spaghetti code, but this is actual spaghetti code. These things with all their wires and so forth, I find extremely difficult to read. I think maybe they're easy to write, but boy, they're hard to figure out what the hell's going on inside them. So I'll stop sharing at this point and entertain any questions about VFX. Let's see, Donato says, makes me consider what color toys to give a dog. That's actually what it says in there. It says, you want to give your dog a blue object or a green object, but not a red object, because they can't see that against the grass. No, but my girlfriend's dog is fixated on green toys. Okay. So lots of talk about dogs there. All right. So anything about VFX? Anything about the relevant topic here today? No? Okay, well, I'm going to stop recording at this point.